Hi, we'll briefly discuss polynomial division. Now, polynomial division you may know from the French version. I'm going to use the English version here. It's a lot like when you first learned how to do long division back when you learned division for the very first time in elementary school. Except, of course, we're going to be using polynomials. We're going to be dividing one polynomial by another. So the way it works is my denominator is going to go here on the left. And then underneath this little line I've got here, I'm going to put my numerator. And then I'm going to look at the highest degree term in both my denominator and that numerator and ask myself, how many times does x go into 4x squared? Or put another way, what do I have to multiply x by to get 4x squared? And the answer is 4x. If I multiply 4x times x, I'll get 4x squared. But then I have to apply that 4x to that plus 5 as well. So I have 4x times 5, that gives me 20x. Now, I'm going to take away, we've got part of our answer here, I'm going to take away this polynomial here from that numerator. So put brackets around it, and I'm going to subtract each of these terms from the terms on top. So 4x squared minus 4x squared, of course I get 0. That will always happen. And negative 3x minus 20x would give me negative 23x. And then I just play this game over again. I'll drop down this plus 2, and I'll ask myself, what do I have to multiply x by to get negative 23x? And the answer, of course, is negative 23. But then, of course, I have to do that to both of the terms from my denominator. So I'll get negative 23x, but then I'll also get negative 115. I'll put that in brackets and subtract those two, and I'm going to end up with 117. Okay? So we've got our quotient up here, and I've got a remainder down here. Now, what is this telling us? Well, just like if we did long division, that quotient is kind of the whole part, telling us kind of the whole number of times that that denominator goes into the numerator. And the remainder tells us that little bit that's left over, that little extra fraction that's left. So what does that mean for us? It means that our fraction here, this one here, is equal to 4x minus 23, and then plus our remainder over our denominator. Okay? So we have the quotient plus the remainder over the denominator. We've got a little bit of x plus fifths left over. Let's try another example here. Okay. Again, I'll put my denominator on the left here, and then my numerator underneath this bar. And I ask myself, what do I have to multiply 2w by to get negative 8w squared? Well, negative 4w works. I'll do the multiplication of both terms from my denominator. Put that in brackets and subtract it. And I'll be left with 7w minus 24w gives me negative 17w. And drop down the next term. And I ask myself, how many times does 2w go into negative 17w? Or, another way to ask that question is, what do I have to multiply 2w by to get negative 17w? Now, there's not an integer answer to that, but there's definitely a good fractional answer to that question. Okay? If we multiply 2w by negative 17 halves, we definitely get negative 17w. So now we'll do the multiplication. Negative 17 halves times negative 6 would be positive 51. Put our brackets around, do the subtraction, and we get a remainder of negative 62 here. So that means that our original fraction could also be written as this whole polynomial part minus 62 over the old denominator. And we'll see in some future videos and time in class how we can use polynomial division to help us graph rational functions, and also how it can help us to find solutions to polynomial equations. Thank you.